6.3, page 428, talks about permutation and combination. So a permutation is a set of distinct objects, is an ordered arrangement of these objects. We also are interested in the order arrangement of some of the elements in the set. So here order matters. And you notice the combination and permutation are very close. The only difference, one of them order matters, the other the order doesn't matter. An ordered arrangement of R elements of a set is called an R permutation. And the formula in the book, this is the actual formula, but the formula in the calculator reads NPR, and I'll show you where to find it and you could use it. Combinations. An R combination of elements of a set is an unordered selection. That means the order does not matter. Of R elements of the set, thus the R combination is simply a subset of the set with R elements, and we use for that NCR. So the way it works, if I am picking 3 applicants that are applied to Walmart, and I need any 3 applicants to do regular task. I have 10 applicants and I want to choose 3. In that case, the order doesn't matter. Any of the 3 will do. But if I have 10 applicants and I want to choose 3, and out of those 3, I want a manager, a supervisor, and a cashier. Now, it does matter which one I choose as a manager, which one I choose. So I have to do more work for that. Anytime you're going to do more work, or you need the arrangement to be in specific order, then it's a big deal. If I'm going to draw 3 tickets, and the winners will get an iPad each, then it doesn't matter whether I pulled your name the first, the second, or the third. You're going to get the same prize. But if I say, so in this case, it'll be, the number of contestants, choose, which is C, 3. But if I want to choose 3 out of, say, 10, tickets, the first gets an iPad, the second gets $100, and the third will get a $10 gift card. Then it does matter whether you are chosen first or not. Then I use 10P3. So that's how this works. Now, you just have to figure out, does it matter which order I put those in, or does it not matter? If it matters, I use NPR. If it doesn't matter, I use NCR. First question is asking, how many different permutations are there of the set? So we have 1, 2, 3, 4, 5, 6, 7. Now you could do it the long way. 1, 2, 3, 4, 5, 6, 7. There are 7 for the first choice, 6 for the 5, 4, 3, 2, 1, or simply 7 factorial. Or, since the order does matter, you could say it is going to be 7P7. According to the formula, that turns out to be 7 factorial divided by 7 minus 7 factorial, right there, which is 7 factorial over 0 factorial, which is 1. Now, on a test, you could leave your answer like that. For the homework, you want to match it at the back of the book. If you have this calculator, then if you click on probability right there, if you click on PRB, probability, you'll see factorial, you'll see NPR, and you'll see NCR. If you have a calculator like this, you have to find the keys, and they're right there, NCR, NPR. So if I want to go 7, NPR 7, that's 7 factorial, which is 5040. So again, for a test, you could leave it in terms of NPR and CR. For the homework, you should evaluate it to make sure that you're doing this correctly. Now, if I look at problem number 4, it says we have an order of 1, 2, 3, 4, 5 elements. List all the 3 permutations you can get. So in part A, we're going to take 5, choose 3. And in part B, we're going to choose combinations, 5C3. And nothing more than a calculator work. Again, on a test, you could leave it like that, out of mind, 5 NPR3. So that's 60. And 5 NCR3. 60 and 10. So when the order matters, there are more choices. When the order doesn't matter, they count the same. For example, 1, 2, 3, 1, 3, 2, and 3, 2, 1 are 3 different orderings because the order matter. 1, 2, 3, 1, 3, 2, and 3, 2, 1, those are all the same because the order doesn't matter. If you chose those 3, pretty much you're done. So there are 60 ways you could arrange those 5, picking 3, when those are counted as 3 different orders, and this counts as 1 order. That's why there's a lot less of those. So anyway you have 1, 2, 3, automatically that counts as 1. And here just a practice to make sure that you know how to use your calculator. So make sure that you get your scientific calculator and figure this out. So we have 5, choose 1. That's 5. And if I go in and I go back and I make that a 3, that's 10. And if I go for 8, choose 4, that's 70. 8 choose 0 is 8. 8 choose 8 is 1. I'll show you that really quick. I know that from statistics. So if there are 8, so if there are 8 elements and you're choosing all 8 of them, there's only one way of doing that. You choose all of them. And if you have 8 elements and you're going to choose none of them, well, that's one way as well. But I get 8. And if I have 12, choose 6, in which the order doesn't matter. Remember, this is the smaller case. So these numbers are a lot less if the order matters. There's 924. So again, nothing more than making sure that you know how to use a calculator. On a test, again, you could leave your answer in terms of NPR or NCR. How many different orders can 5 runners finish the race if no ties are allowed? Well, the order matters here. And I'm choosing, so we said, I forgot to mention, they write this as NPR or PNR, NCR or CNR, either way. This is how they normally write it, but this is how it is on the calculator. So here, we're going to choose P. We have 5 runners and we're choosing 5. And we're choosing P because it's a race. It doesn't matter who wins it first. And we know that that's going to be 5 factorial ways. Now, no need to worry about the algebra. Take 5, P, 5, and that gives you 120, which is 5 factorial. There's 120 different ways that could happen. There are 6 different candidates for governor of a state. Okay, governor of a state, it doesn't matter who you pick. In how many different orders can the name of a candidate be printed on the ballot? So you want to print those on a ballot. Well, you're going to have to print all of them. So out of the 6, you're going to choose 6, which is really 6 factorial, and that's 120 to 720. 120 times 6. A factorial is the fastest growing function in math, after a given number, of course. Now, changing slightly. Number 12. How many bit string of length 12? So we have 12 of those. Contain exactly 3 ones. Well, it doesn't matter where the ones come in. So out of 12, choose 3. 220 ways. Okay, how about B? Let me just get everything up. Okay, at most 3 ones. At most 3 ones, that means no ones, 1 1, 2 ones, or 3 ones. Now, you know what? We should write so it mix things. So, the way it works, no ones, well, that'll be out of the 12, we're going to choose none. Or, since you have a choice, out of the 12, we're going to choose 1. Or, out of the 12, I know this looks long, but believe it or not, this is the shortest way of doing this. I plug this in my calculator, and that turns out to be 299 ways. Again, on a test, you could leave it just like that. Now, the word at least is a big mess for us. So we have a string of 12. We could have none, or 1, or 2, or 3, or 4, or 5, or 6. The reason I'm going in details over this because we're going to use that in many sections. So let's get that out of the way. When it says at least 3, 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12, it's this. Or we could say that's the total minus what's left. None, or 1 1, or 2 ones. So this is really useful for most of the at least. So the total will be, well, that's string of 12, 2 to the 12, right? Bunch of zeros or 1 minus, and this is none, it's right there. 12, choose 0, or 12, choose 1, or if you have a choice, you add 12, choose 2. Plug that in the calculator, that turns out to be 417 ways of doing that. So at least, anytime you see at least, if you list all of them, it'll be the total, and you take that, so it's like 100 minus the lowest. An equal number of zeros and ones. Well, an equal numbers, that means 6 zeros and 6 ones, right? Well, 6 ones, that'll be in any order 12, choose 6. And that turns out to be 924. All right. The next number. How many ways can a set of 2 positive integers less than 100? So from 1 to 100, that's 100. But we want it to be less than 100, so really to 99. So it doesn't matter which two you choose. So we have from 1 to 99, that would be 99 integers. Can you choose two positives? And that's 4,851. All right. Now, a coin is flipped, and when you flip a coin, you have kind of like the bit string, right? So the options, you could get a head or tail, one of two options. It says a coin is flipped 8 times, where each flip comes up to be either a head or a tail. How many possible outcomes are there in total? In total, well, heads or tails each, 2 each, and there's 8 times. That's 256 possibles. B. Contain exactly 3 heads. Well, it doesn't matter where you get the 3 heads. Out of the 8 possible, choose any 3 heads. That's 56 ways that could happen. When it says at least 3, again, we're down to the same problem. No heads, 1 head, 2 heads, 3 heads, 4, 5, 6, 7, or 8. And again, I'm going to stop doing that pretty soon. So at least 3, 3 or 4 or 5 or 6 or 7 or 8. That will be the total minus no heads, 1 head or 2 heads. So C of 8 choose 0. Plus C of 8 choose 1, plus C of 8 choose 2. And if you plug that in the calculator, that turns out to be 219. Contain the same amount of heads or tails. Well, same amount of heads or tails, you're doing 8 of them. So we're saying out of the 8, choose only 4. And that's 70 ways of that happening. How many ways are there for 10 women and 6 men to stand in line so that no 2 men stand next to each other? So they alternate. Now, if you think about it, if I have, so they give you a hint. They say first position the women, then consider positions for the men. Okay, if you want to stand the women in order, out of 10 women, you're going to choose all 10 of them. And now we get to the men. We're going to choose 6, but one catch. If I have a woman standing, one woman, do you see that there are 2 possibilities for a man to stand around? And if I have 2 women, can't I have men stand on either side? So keep in mind, for the first position of a woman, I add an extra position for the men to stand on either side. So if there are 2 women, there are 3. If there are 3 women, there are 4 positions in which men could stand. And if there are 10 positions for women to stand, then around them there should be 11 spots I could choose from to put men in. And this number turns out to be massive. And this is how you do it on a calculator. You don't write anything down, you just do the, as you see it, 10 permutation 10 times 11 permutation 6. There it is. All right. So again, positions and filling those positions in. 13 people on a softball team show up for the game. How many ways are there to choose 10 players to take the field? They didn't say in which order. So that is combinations out of 13, choose 10. In any order, it doesn't really matter. B. How many ways are there to assign the 10 positions by selecting players? Now you're selecting, you're doing more work. So now you're doing P of 13, choose 10. C. Of the 30 people who show up, 3 are women. How many ways are there to choose 10 players to take the field if at least one of them must be a woman? At least one is a woman, and we're talking about 10. So at least 1, 2, 3, 4. That's the total minus no women. Well, the total in this case is 13, choose 10. And to choose no women at all, there's only one way of doing that. You have to choose all men. And whatever that works out to be. I can tell you what the answer is. We could do the answer to all of those. So if I take 13, choose 10, that's 286. Then this is 286 minus 1, which is 285. That will be the answer in the back. And if you do the permutation to figure out part B, you would say 13 that number, massive. And the last problem I have, a professor writes 40 discrete mathematical true or false questions. Of the statements in these questions, 17 are true. So there are 40 questions true or false, 17 of them are true. If the questions can be positioned in any order, so the order in this case doesn't matter, how many different answer keys are possible? Well, in this case, out of the 40 questions, 17 are true, whatever that number is, because the order doesn't matter. And if I go for 40, NCR 17, that many. Too big of a number. And that's pretty much it for this section.